So with this lesson, so this is not on your quiz tomorrow. So I just want to preface that. That's not on your quiz tomorrow. That is on your quiz next Wednesday. So this one is taking translations and stretches and reflections, and we're going to do them to the same function. All right? So the first thing I start here is order matters. You must stretch, then move. So any stretches, but it's order of operations. It makes sense. Stretches and reflections are about multiplying, and moving is about add and subtracting. So it's not out of your skill set because you've seen this all before. So stretches have to deal with things that we multiply, and then moving has to deal with addition and order of operation. Whenever you actually learned order of operation, that's the way you did it in the order, right? We deal with our multiplies first, and then we deal with the add subtract stuff. So stretch the move. You want to stretch before you go and do a big physical activity. Don't talk to me about dynamic stretching or anything like that. I understand, but this was my cute way of trying to remember. So stretch, then move. So when I talk about move, I'm talking about a translation. So that's just not changing the shape, but physically moving it around the coordinate plane. All right, putting transformations together. That's what we're going to do today. So this is our parent function right here. And so let's label some points on it. I will tell you that that's -2 and that's +2. That's 2 and that's -2. Hopefully that's helpful. If you can't see that, it's kind of hard because it's right on the lines. Let's label some points because that will work way better for me. I'm going to do a table of values just because it makes more sense. So I have -2 and +2. I have -1 and +2. I have 0 and 1. I have 1 and 1. And I have 2 and 1. Okay, so those are some coordinates. I mean, we could get fancy and go into halves and stuff like that. But why would we? That seems like a lot of math. Let's stick with whole numbers. Or integers. Okay, so this is in function notation. So it's telling us the rules. It's giving us instructions on what to do to all those values. So let's go through it. Do you want to make it into a mapping rule or do you want to put it in words? We can do both. Okay, words above. So what is this 2 out front telling me to do? Okay, multiply y's by 2. Okay, that's the first thing. And I always do it in the order like left to right, like I'm reading a sentence. You don't have to do it that way because some people are like, hey, Scallion, I'm already talking about y's, so I want to hop to the end here because this has to do with a y. Right? So do you want to, let's do all of our y stuff first. So out front and at the end. They're kind of the earmuffs of the function notation. So we are going to move down by 2, but that's going to tell us that we are subtracting y's by 2. And then what about that 3? So the x's add 3. Okay, so if I were to make this into a mapping rule, okay, what did I do to my x's? You just added 3. So x plus 3. And then the y's, we multiplied by 2, and then we subtracted by 2. So 2y minus 2. So, okay, yeah. Okay. So it really all depends. When I get this question, I find it handy to put it in some sort of description, like you're translating it out of function notation. So if words make sense to you, do that. If the mapping rule makes sense, do that. Remember that it's the straight math. In the mapping rule and in the words, you're actually telling us what math you're doing. Okay, so now we got a new table of values. All right, so here's my old table of values. What am I doing to the x's? Adding 3. So that should be at 1, 2, 3, 4, 5. Look at that, I added 3, everybody. Did good. Let's talk about the y's. So this is where order matters. You have to multiply and then do the subtraction in this case. So 2 times 2 is 4. 4 minus 2 is 2. And then, well, hopefully if my math still stands, that should be 2. 2 times 1 is 2. Minus 2 is 0, 0, and 0. I don't have to continue to calculate it, right? So we expected our graph to get really kind of stretchy because it was a factor 2. So we would have had this like, we're stretching our graph top to bottom. But because we also had a move, all of a sudden that compression isn't going to be as straightforward, or sorry, that stretch isn't going to be as straightforward as it was in yesterday's lesson. So now things start to look a little wonky. So let's plot these points. 1, 2, 2, 2, 3, 0, 4, 0, put 5, 0 out there. I'm going to use my handy dandy ruler. And it should be a similar shape. Any arrows on this graph? No. So I just want to point out to you there was a stretch. Like if you look at this slanted line here, the slant line happens on the diagonal of one box. The slant line here happens over 2 boxes. So there has been a stretch. This graph is taller, but it's just not in the location it said it was going to be, right? Because we had those moves to it. Okay, here we go. I have another color, I know I do. Any questions about that graph? Any concerns about that table of values? Okay, let's talk about this. So function notation is just telling us what the instruction or the rule is to do to this table of values. So what's this telling me to do? Right, so we're going to multiply y's by -1. Really what you guys need to know is the math, and that's what you need to know, like the multiply by -1. Which one? What does it result in though? A reflection along the x-axis. So if you can see that in your mind's eye, that will help you, because then you'll know if your graph is kind of right. This is what you definitely need to know. Okay, let's talk about that one. Multiply x's by 2. Okay, I'm going to squish in my table of values over here. So my x's are getting multiplied by 2, and that's the only thing I'm doing to my x's. So this will be -4, -2, 0, 2, 4. And then my y's are getting multiplied by -1. So this is going to be a -2, a -2, -1, -1, -1. So what we anticipate is our graph getting really long in this one because we've got a horizontal stretch by a factor of 2. Like we're making it longer, but we've also flipped it upside down in relation to the x-axis. See, and this is where people like me struggle because you're doing so much visualizing that for me, I have to trust my math. So -4 and -2. -2 and -2, 0 and -1, 2 and -1, and 4 and -1. So it did what I thought it was going to do. It was going to be a really stretchy graph. Again, I'm using my handy dandy ruler. So notice that there has been no vertical stretch there. The diagonal on this one was 1 box high. The diagonal on this one is 1 box high. But now it's 2 boxes long. So you guys good with that? Okay, good. All right. When you get it, it makes a ton of sense. It's just sometimes when you don't get it, becomes frustrating. All right, deep breath. Okay. I'm going to call that big wide one f of x. Because if we call the other one f of x, like if you call the little one f of x and I call the big one f of x, we're going to have different transformations. All right. What value of y, here's a quizzle question for you. What value of y is not affected by any vertical stretch? 0. Doesn't matter what I multiply by 0, what is it? 0. So if you have a y, so on your, I don't know how to, I'm going to say the words and then we'll figure out how to put it down on paper. So if I want to know where my vertical shift is, I have to look for a place where y is equal to 0. And you get, like, shift is the movement. Because that's the only place that the stretch won't affect it. Does that make sense to everybody? Okay, nope, I like it. At least somebody's honest. So to find a vertical stretch, oh, you guys can't even see that. To find a vertical stretch, no. What do I want to do? I want to find a vertical shift. Find where y equals 0 on f of x. Because a vertical shift is going to be applied to the y's. Right? Yes? Everybody with me? Okay, we're just going to have to trust me for a few minutes and hope that my explanations are good. So would you guys agree that this is a spot 0, 0. It's got a y value of 0. And that would match this spot on the image graph? Yeah? You guys would agree? Perfect. I like when we agree about stuff. I want to point out some things. So that pointy part, I won't call it a vertex because it's not a vertex. This is not on a parabola. See these points right here? Okay, see those points? They match with these points. So on a graph, if you have points that are definitely labeled, they match each other. So this point translates to that point, transforms to that point, and this point transforms to that point. Make sense? Sorta, kinda? Just like this point transforms to that point. Okay, so if I went from here, what's the height of my new pointy part? 2. So where did I go? I went from 0 and I went up to 2. So what is my d value? Plus 2, right? Because I'm going up. Now, notice that there's an f in here. So right away, that means that we are doing function notation. This is an absolute value graph, by the way. But as soon as we have that letter f in there, we're doing function notation. So we're just doing the rules. We're just saying what you do to all the points on the graph. Okay, so same premise here. If I want to find a horizontal shift, I'm looking where x is equal to 0 on my original graph. Okay, so we went left, how many? 1, 2, 3, 4, 5, 6, 7. We went left 7. So what is C going to be? Okay, in the equation, it's definitely going to be plus 7. Okay, we'll go with that. Okay, so D we said was 2. C is actually going to be a negative 7, because when you put it into the equation, what's going to happen to it? It's going to be like subtract a negative, which changes to a positive. Okay. All right. Okay, there we go. Are we good? Sorta, kinda? Okay, we did our shifts. To find the stretches, we're going to look at let's do vertical first. So you're going to look at the vertical distance between 2 points on your original graph. And so I'm going to look at the vertical difference between these 2 points, 0 and 4. So what's the height of that graph? 4, okay? So then on this graph, I'm going to look at the translated points, the matching translated points. What's the height of that graph? 8. All right. So what mathematically do I need to do to 4 to turn it into an 8? Multiply by 2. And we know it has to be a multiply because we're dealing with stretches, and stretches are all about multiplying. So we know we have an A value of 2. Any reflections on this thing? We actually wouldn't know. We'd know if there was a vertical or like a reflection in the x-axis. Would we know if there was one on the y-axis? No, we couldn't tell because they're the exact same points. They're symmetrical. Okay, now we're going to do the same thing with the horizontal. I'm going to go the distance between 2 points. What's the distance between those 2 points? Is it 8? Okay, if that's 8, then what's that? That's 2. So if I was at 8, what did I have to get to 2? Times by a quarter. So the math is times by a quarter. So what's our B value? Right? So for our horizontal stretch, we're going from 8 to 2. So we have to multiply by 1/4, but that means, therefore, B is equal to 4. Does that make sense to everybody? That's a confusing one, and it's really easy to get mixed up. So as you're learning this, cut yourself some slack. It will take some practice. So let's put it all together. I'm running out of colors of pens to put it all together. We'll go with the handy dandy green pen. Where's my green pen? All right. So y equals, what's our A value? 2. F. And then what's our B value? 4. And then this one's going to be the x plus 7 because you went left. And then we are going to close that big bracket again. And then we're going to have plus 2. So that is our answer in all of the gobbledygook that I wrote there. Yep.
Doesn't that go against like multiplying first though, since the x plus 7 is kind of first?
X plus 7. Okay, remember that these are instructions. They're not the equations, right? So you got to remember, as much as like it looks like an equation, we put f of x as an equation before. This is just the math language instruction. That's all this is giving us, is the rule of what we do. So yeah, I get what you're saying. That ruins it all in order of operation, but this is just telling us what we do. And when we apply it to the table, you have to be using your order of operations. Okay, all right. I'm going to leave you to do the try it on your own one. Try it on your own. So these points translate to those points. So we're going to go f of x is your parent function. Ladies and gentlemen, you may want to start with your do we all agree there's a reflection? Start with your reflection first. Because if you say that you've shifted 4 units down, is that correct? No, because you have to reflect first. Yep. So what's it gonna attach to? Yeah. So yeah. What? What are you talking about? There's no what? Okay. All right, hang on, guys. I don't know where you're getting the 3 from. You're doing your try on your own. That's what we're doing. Okay, let's talk about this for a second. The first thing I notice is that there is a reflection in the x-axis, so I know it has to do with the y's. So I'm going to deal with my vertical stretch first. Because if I reflect this, where do these points turn? Like if I just reflect this and do nothing else, would you guys agree that that's a reflection of that one? Yeah? Okay, if you can do that first, then you can do your shifts and your moves accordingly. Does that make sense? So let's talk about the verticalness of this one and the verticalness of this one. This one has a height of 1, and this one has a height of 3. So how do I get from 1 to 3? What math? If I'm doing a stretch, I have to multiply by 3. But we also know that this would result in a reflection. So what kind of has to be a -3? Okay, so once you've dealt with your reflection, so notice how I just took this and reflected it. So now I can start talking about how this point moved. How did this point move? Okay, we'll do it. We'll see where you get. I froze the screen again, so you can't see me working. Uh-huh.
When you do the points on the x-axis, is it still going to be negative or no?
Okay, I don't understand your question, Danica. And then Basil, I will try to understand your question.
You just did -3, like with the.
That's a stretch, yeah.
What about the ones across them?
What about them? We're not doing point by point. Remember, we're making the rules. You're making a rule for this. You've got the 2 graphs. Now you're making the rule. Okay, Basil, what was your question?
I think what's asking is, would we have to make the b value negative as well? Because it's like our reflection, but it's not a reflection along the y-axis.
But it's not a reflection in the y-axis. It's a shift.
Okay.
Right? Okay, I think I got mine. You got it, Amber? Or are you just waiting for me to get it?
No, I looked at it, and, I got a little stressed out.
Okay, fair, fair. You have until next Wednesday to emotionally process this. You got it. Can I show you guys? Okay. Yeah.
In the top one, we did do.
Okay, Jacob, I can't hear words. I'm sorry.
In the top one, was it supposed to be a four? Because I have.
Yeah,
Why is it negative 4?
because I shifted down. Okay, all right, let me walk you through all the pieces. Let me walk you through all the pieces, and hopefully I'll explain stuff. If I don't, I promise I will answer the questions. I have my handy dandy highlighter. Okay, does everybody get the reflection? We kind of did that one together. Does that make sense to everybody? So even if it was a negative stretch, that will not affect my shift, because 0 times by a -3 is what? Still 0. So here, you guys would agree my point is 0, 0, right? So y went down 1, 2, 3, 4 to get to its new vertex. And while we're here, we might as well do C as well. We went 1, 2, 3 to the right. So if you can find a place where x is 0 and y is 0, your stretches are really your shifts are really straightforward. It's unfortunate, though, when you can't find the 0, 0 or zeros for each of them, it becomes a little bit more cumbersome. Not impossible, but cumbersome. Okay, so let's talk about the half. I wrote myself a note over here. So I looked at the horizontal width between these 2 points on the original. I said that has a width of 2. Everybody would agree with me? The new graph has a width of 4. So to go from 2 to 4, I had to multiply my x's by 2, right? The rule is So the rule, I'm telling you, is to multiply by 2. That's a straight math, but we know that the b value is always the reciprocal of it. So when I put this together, y's are by -3, x's are by 2, because we always multiply by the reciprocal of what's in function notation. I'm going to shift 3 units to the right and 4 units down for every point. If you want to check to see if your function notation or if your rule makes sense, grab the points from this. So let's take this point. This point is 1, 1. Would you guys agree with me? That point right there is 1, 1. Okay, let's apply everything I just wrote here and see if we end up here, which is 5 and -7. Okay, so if I did everything right, that's where I should be. I've got the graph, so I can check. So this is, I'm going to grab the pencil. Okay, so 1, 1. So what do I do to my y's? Times by -3 and -4. So 1 times -3 is -3, subtract 4, -7. This is looking good. Okay, let's go to our x's. What's this telling me to do? Times 2. So x times 2, or 1 times 2 is 2. And then this tells me add 3. So 2 plus 3 is 5. So my rule matches my graph. So that's a way to check, like if you're doing this on a test or a quiz, a way to check to see if what the rule you made makes sense to the graphs you see. Okay, times. Good times. We're doing great. We're doing awesome. Okay. Oh, this is a trick question from grade 11. And do you see the problem? Look at the format I gave you at the top of the page versus the format at the bottom of the page. What do you notice is missing? Another set of brackets. So this is not in the correct function notation format. This was a trick question when it came to your quadratics, when you were doing it in vertex form. So what do we have to do before we can look at the rule? Get a common factor. Exactly. So common factor that. So I'm going to have y equals -3 big bracket, -2, bracket, x minus 2, big bracket, plus 2. That's a trick. That's a trick, and I'm mean and nasty, and I might throw that one at you. No, okay. But I showed you that I'm gonna do it. So just know that you have to have the 2 set of brackets in function notation. So sometimes when we get math fatigued, missing stuff like that is really, really easy. And math fatigue has nothing to do with whether you understand it or not. It's how long you've been writing for, how painful it's been, how upset you are, and if somebody's texting you and it's time for you to go home, right? Like, those are all things that happen with math fatigue. Okay, so now we can answer the question. You have a point on the parent graph. Parent graph, 4, 3. You apply the transformation of this. What are the coordinates of the transformed point? Should we start with our x's? I just feel like that comes first. So what am I doing to the x's? Dividing by what kind of 2? A -2. So 4 divided by -2 is -2. Add 2. So I was at -2, and now I'm adding 2, so I'm at 0. Okay, now let's go to our y's. 3 times -3 plus 2. So I'm going to say that this probably would be a 2-mark question, and if you didn't factor it out, you'd probably get 1 out of 2 marks for that. All right. Wait, what? Then you'd get 1 out of 2 on that, just because you wouldn't, this would be the wrong shift, right? It's in the wrong direction and it's for the wrong amount, so you wouldn't get that point for that part of it. So you get the points for applying the vertical stretches, but you just would miss the point for that horizontal shift.